So now let's do some examples of DeMorgan's theorem. So DeMorgan's theorem, we're going to start at the top or the outside parentheses. So if we had some extra parentheses or brackets here, that would be the outside parentheses. And we do that so we don't have to, basically perform DeMorgan's and then perform DeMorgan's again. We can use involution instead. So we're going to start at this bar. We want to distribute that bar. So we're always looking for this pattern, either terms that are ANDed together under a bar, so we can distribute that and turn that into an OR expression with the terms complemented, or an expression that is an OR expression under a bar that we can then distribute the bar across each of those terms and then AND those terms together. So that's it, right? We do that single step. We either look for terms that are ANDed together under a bar or together under a bar. So here we can see we have some term, that left term, and it's ANDed together with that right term under this big bar here at the top. And so now we can distribute that by taking that AND, turning that into an OR, bringing down the terms, A or B, D, all of it bar. That's my left term. My right term is C bar. And then the last step is to put a bar over each of the terms. I do that in those 3 steps, right? Bringing the AND down, that's the first step, changing it into an OR. Second step is to bring down each of the terms. And the third step is to put a bar over each of those terms, because sometimes people forget, and then they forget, they're like, oh, I already barred C. No, C was already there originally with the term. And now we can perform involution. I say don't do more than one step at once, but if they're on independent terms, so for example, I'm going to do involution on this term on the right, and C bar bar is just equal to C. And separately or independent from that, I'm going to perform DeMorgan's on this left term here. And so we have a term that's ORed together under a bar. So we take that OR term, that OR operation, turn it into an AND operation, bring down each of the terms. And I can keep the parentheses here and get rid of them when I need to. And then last step, I'm going to bar each of those terms. So a 3-step process, change the OR into an AND, bring down the terms, and then third step is to put the bar over to distribute the bar across those terms. And again, we can see that we have involution here on this right term, on the BD term. So I get A bar, BD, or C, and now I just get A bar, BD, take off the associativity there, or C. And so now I've simplified that expression or that equation, and now it's in minimized SOP form. So here's another example. Again, we're going to start from the outside and work in, right? The outside parentheses and work in. We have a bar over terms that are OR together. I could actually take off these inside parentheses if I wanted to, but we'll go ahead and kind of leave it like it is. So we have this term on the left ORed with this term on the right. We'll bring down each of those terms, A, C, bar, and E, or D bar. Change that OR into an and then last step is to put bars over each of those terms. And now I'm going to take a look at this expression here on the left, and I see that they have 2 terms ANDed OR together, and so I take that OR, I turn it into an AND, I bring down each of the terms, and last step is I put a bar over each of those terms. And then I bring down that last term. And now I can see on this left term here, I can perform, well, I have terms that are ANDed together, this term on the left, and this term on the right, they're ANDed together with a bar over them. And so I change that AND into an OR. I bring down each of the terms, keep my associativity there. If I want to keep that one, I can too. And then last up is to bar each of the terms. And then I can see I can do involution on this term. So d bar bar is just equal to d. And then I AND that all with b bar. You can see how I keep it aligned. Makes it easy for me to double check that I didn't drop a bar or do something, change an AND to an OR or something where I wasn't supposed to. And so now I'm going to do involution on this first term. AC bar bar is equal to AC or E bar, and D, and I'm going to go ahead and get, I know I can get rid of associativity there. There's all terms that are ANDed together, D and B bar. And it's still not in minimized SOP form, getting close. But now I can either, I'm going to go ahead and distribute this across, this term across that OR expression. I'm going to go ahead and put it in alphabetical order too. Well, actually, I'll leave it like this for now. AC, D, B bar. That's that. And then OR, E bar, D, B bar. And last thing I'm going to do is I'm going to put each of those product terms in alphabetical order. I'm going to get A, B bar, C, D, or D, B bar, B bar, D, E bar. And now we have the minimized SOP form of that expression. So I want to point out a few common mistakes with DeMorgan's theorem. So the first one is to try to do too much at once. So if we have some equation here, y equals AB bar or C or something, all of that with a bar over it, people will try to do this all in one step, right? And they'll be like, okay, well, ANDs go to ORs, and then A or B bar, this OR goes to an AND, and then, I don't know, I guess just put bars over all of them, which, you know, is actually not too far, but some mistakes in that. So instead, do it one step at a time. We're applying either an expression that has a bar over it that's an OR expression. So in this case, that's what the case is. We have a bar over an OR expression, or a bar over, you know, an AND expression, or something like this, right? So if we had another expression or equation over here, this one we would take as a bunch of terms that are ANDed together under a bar. So those are the two cases, either terms that are ANDed together under a bar, that we can then distribute that bar, or terms that are ORed together under a bar, and then we distribute the bar. Those are the two cases that we can do. So in this case on the left, we have A and B bar or C. So we have an expression, an OR expression under a bar. And so the left term, we bring that term down. We change the OR into an AND. Now we bring the right term down. And then finally, we put bars over each of those terms. Now the other thing, this is another common mistake, is not to keep associativity. So this entire expression is going to be ANDed with C bar. So when I perform DeMorgan's on this left term, I want to make sure that I keep that associativity. So here we have an AND, turn it into an OR, we bring down the terms, and we bar them, each of those terms, and I also keep that associativity. So that entire, whatever that evaluates as, needs to be ANDed with C bar. If I forget to keep my associativity, well, now I get this ANDed together first. So instead, I do this, and then I get equals A bar, or involution on the B bar bar is equal to just B, and C bar And now I distribute that C across each of those terms, and I get the C bar across each of those terms, and I get A bar, C bar, or B, C bar. Let me show what would have happened if we'd done the wrong thing, or if we hadn't kept associativity at this point. We would have gotten A bar or B, right? We still get involution on that. But if there are no parentheses here, right, we forgot those, and we get and C bar, and now we're done, right? That's our entire expression. We get A bar or B and C bar. That's wrong. That's not correct. Okay, so that right part is the mistake. This left part is the correct way to do it.